Welcome to our second Barney Gibbens lecture. Hermann Hauser is probably best known for his part in setting up Acorn Computers in 1978, which produced the BBC Micro, widely used in schools in the 1980s. And since then, he has founded or invested in multiple businesses and helped them grow. And in 1997, he co-founded Amadeus Capital along with Anne Glover. And Amadeus is now one of our leading venture capital companies. He holds many honorary positions, honorary doctorates at the University of Bath, Loughborough, and Anglia Ruskin University. He's a member of the Advisory Board on Higher Education Innovation Fund and of the UK's Council for Science and Technology. In 1984, he was voted the UK's Computer Personality of the Year. In 1998, he got an honorary fellowship at Hughes Hall, Cambridge, followed by one in 2000 at King's College, Cambridge. In 2010, he was voted one of the most important scientists in the UK. He's an honorary fellow of the Institute of Physics, an international fellow of the Royal Academy of Engineering, and in 2012, he became a fellow of the Royal Society. In 2013, he became a distinguished fellow of the British Computer Society, and in 2015, an honorary KBE. I've left till last the fact that he was involved in spinning out advanced RISC machines, known as ARM, from Acorn in 1990. It became the world's leading designer of chips for mobile phones, which was bought in, I think, 2016 by Japan SoftBank. I've left this to last because this leads me to Sir Robin Saxby, who is an honorary liveryman of the company. He was ARM's first CEO between 1991 and 2001, when he became the chair until 2007. Having helped build the company into a $10 billion corporation, I think I'm right in saying shipped over 100 billion chips, or at least designed 100 billion chips, and are in 80% of the world's phones. It has become the most popular microprocessor architecture on the planet. He received the Faraday Medal of the Institute of Engineering and Technology. He himself became a KBE in 2002. And in 2006, he was the annual president of the Institute of Engineering and Technology. He too is an honorary fellow of the Royal Society. And in 2019, he gained the Founders Medal of the Institute of Electrical and Electronic Engineers for achievements in developing a globally successful electronics enterprise with an innovative approach to licensing of intellectual property. He holds honorary doctorates from the University of Liverpool, where he's a visiting professor, as well as from Loughborough University, the University of Essex, Nottingham-Trent, and Anglia Ruskin. He's interested in renewable and alternative energy sources and in supporting business startups. He isn't just interested in putting money in, but he's much more interested in the ideas and the people that he likes. His advice is that startups, they should expect their first product to be a failure. And then as you grow the company, be sure to recruit the best people. And I suspect now we'll hear more from both of them about this. So welcome, Robin and Hermann, over to you.
Shall I start with a story why the ARM exists at all?
Yes, because I failed to sell you the 68,000.
That's correct. The 6502 was the 8-bit processor that we had in the BBC Micro. And we were desperately looking for a processor, a 16-bit or 32-bit processor, because we needed more performance. We finally thought that the Intel 286 was the right processor. So we went to Intel and said, the 286 is a good processor that we would like to use, but we looked at your pinout and we realized that because you had the data bus and the address bus on the same pins, nobody can make a sensible computer out of it. But if you just sell us the chip, we'll change the pinout and maybe we can make something of your chip, being, rather arrogant in those days because we were riding so high. And they, to our surprise, said, no, they're not going to sell it to us. So we said, well, if you won't sell it to us, we'll do our own. And that's the reason why we did the ARM. And the 68,000 was one of the architectures we looked at that Robin was very keen to sell us, but we decided we didn't want that either.
So Hermann and I have met, that's 1980. We first met earlier than that when I was at Motorola. We went skiing together in Hermann's hometown. And the good news is Hermann and I, that's more recent, we still ski together. So my message to younger people is, if you do stuff with good people, You can still ski when you get old. And again, that's the other message. It's good that we've got this technology of the internet and connecting us. So that's why you're in my lab. And I've got lots of things to show you. So Hermann and I have known each other for years. We've done some good stuff together. Again, he's got me to invest in Amadeus, and I'm on the advisory board, and we're still mates. And life's been okay. And so my message to everybody, in spite of COVID, life can still be okay. And my thinking is, Hermann and I, we can like chat to each other because we know each other. And the other thing that happens when you're successful, a lot of false information happens. So really, Hermann did a great job with Acorn. I did fail to sell him the 68,000, and that created my career with ARM. So back to you, Hermann.
Well, Robin, maybe you start us off with the Archimedes, because I
Yes.
understand.
Yes.
So we decided to do the ARM, which worked first time and was a fabulous. Maybe I ought to just tell that little story.
Is the video feed here? So I've got an Archimedes. This is 1990 vintage. It's on my desk, and if you look at that, you can see there's a printed circuit board, and it's absolutely full of chips. So in the old days, you designed silicon, but you put the silicon in chips, and you put the silicon on the printed circuit board. What I've got here is today, and a friend of mine, Dave Jagger, who is a Kiwi, is a friend of Hermann and I. This is an Acorn computer running on a Raspberry Pi. He's put the Acorn logo on there using 3D printing. That Raspberry Pi is about 1/100th the cost of the original Acorn Archimedes, about 100th the power consumption, and the floating point processing is 5,000 times faster. And that, by the way, the first ARM I worked out, Hermann, was in 3,000 nanometers. Today's state-of-the-art chips are in 7 nanometers, right? So Hermann and I have ridden the silicon wave. Back to you, and perhaps you'd like to talk about the Archimedes, Hermann.
Yes, well, the reason why the Archimedes exists at all is that we decided to do the ARM, which was designed by Steve Ferber, professor of computer science at Manchester now, and Sophie Wilson. And when the chip came back it was designed, the design tools. I'm sure you're all aware how design tools are now so valuable that Trump could use it to basically get his way with all the other nations in the world, because he could say, if I don't sell the design tools to you, if you don't do as I say, I will stop selling, giving you access to the design tools. Well, the design tools that we used for the ARM was the BBC Micro and BBC Basic. So Steve Ferber actually designed and simulated the ARM on the BBC Micro. So it came back, and I'm the perennial optimist. So I bought 2 bottles of champagne to celebrate the success of a completely new microprocessor, which I expected to work first time. We plugged it in, and of course it didn't work. Great disappointment. However, within 2 hours, they managed to find the flaw, and the machine sprang to life, and it said, "Hello world, I'm an ARM." And then Steve decided to measure the power consumption of the ARM. And the way one did it in those days is you disconnect one of the pins and put a wire with an amp meter in between the power pin and find out what the current was. And as he was bending up the pin, he realized that pin was not connected. So we puzzled over this, because this was a chip that could work without any power at all. So this was the first indication that we got the power consumption right on this chip. And the reason why it worked at all was that the leakage current from the data pins was enough to power up the computer. So this bode well for the low power aspect of ARM going forward. But Robin, you then got involved when we already had, of course, the Archimedes, but we decided that nobody would want to buy a microprocessor from a potential competitor, which also brings us to today, because we don't want NVIDIA to buy ARM, because you don't want ARM to be the world's most successful licensing company owned by one of its licensees. But so we decided to spin it out because it had to be independent. And I think one of my greatest contribution to ARM was to help hire Robin to actually be the first CEO. So Robin, over to you. You got a dowry of a good processor, but no money.
Oh, okay, so here's my history. So my hobby as a kid was electronics. I built transmitters. By the way, I've got some other props here. So this, in the old days, we had thermionic valves. This is one of the world's first valves. It's 1904. It's made by Osram, and it's a diode. The transistor is a little bit younger than I am, but the transistor is 1947 vintage. And I worked for Motorola, Great American. I was involved in chip design in my youth in '68, made by Plessey. So it's like the chip industry took over my life. And I worked for Motorola for 11 years. And that's when I failed to sell Hermann the 68,000. But in the meantime, I was involved in a European startup called European Silicon Structures. And what I'll just show you, these are some ES2 chips. So the idea of ES2 was that we could design full custom chip. Everybody could design their own full custom silicon. And this again is when I still knew Hermann, because Hermann was director of research
for Olivetti.
And we had Saab, Philips, and so on. So ES2 had this great business model to design these fantastic chips. And we made the chips with an e-beam machine, and the e-beam machine's throughput was a tenth of the spec. So the financial model of the company was broken. But we learned about full custom chip design. We learned about silicon design tools. And then what happened is, while I'm with ES2, I get this phone call from this headhunter saying Acorn are thinking of spinning this out. Apple are thinking of investing. VLSI Technology, who were my partners in the silicon world, are putting some money. And I knew all these people. It's also worth saying the importance of European R&D collaboration, because within ES2, we'd work with Olivetti and all these other companies. Another thing which is key, again, for ARM, it's great. We wanted to be a global standard. And the Open Microprocessor Initiative helped us create the AMBER bus as a standard. And in that we had Philips, Nokia, etc. So again, I'm very worried about little England on its own. That's not going to work. The good news is I'm not really a politician, but scientists and engineers collaborate with each other, whatever the politicians say, and look at the fantastic job they've done of bringing out the vaccine. So when we started ARM, the headhunter called me, this is before the company was created, and said, well, they want to do this. What do you think the business model should be? And very simply, the seed capital to ARM was £1.5 million from Apple, £250,000 from VLSI Technology, and Acorn putting in 12 engineers, some working Archimedes stuff, no money, and that was it. And the competitors had got hundreds of millions of dollars, and all the competitors were Intel, Motorola, every semiconductor company, because these all turn into licensees. So the question for me before the company was created was, what's the business model? And I said, the only way we can succeed is if we become a global standard. And because of my experience at Motorola, and because of my experience at ES2, I could see the advantage of creating a standard. And I'm going to go over to the wall here and get my son to do it. So the idea of ARM, I also said, we'll make chips over my dead body. I'm still alive and ARM hasn't made chips. So the idea was, we will create a global standard digital engine that everybody can use. And what I want to show you here, this chip, hopefully you can see it. This is the ARM 610. That is the first chip that ARM did as a commercial activity. It was used in the Apple Newton. The Apple Newton was this handwriting tablet. And so we had to design that chip, and we took what Acorn gave us and we created that. That chip was made by Plessey, by the way. And again, to give you an idea of technology, there are 360,000 transistors in that chip. And the idea of the digital engine, in that chip is the digital engine. This is the digital engine. For Hermann, this was the ARM 2, but for ARM, this was the ARM 6. This was our first independent product. And that engine, you can see, goes in the middle of that chip. This is cache memory and other things. So the idea was everybody could design their own chips using ARM standard engines. And so every semiconductor partner of ARM put their own technology around the ARM core to create unique chips. And here on this page, these are some of the chips. So basically, Apple's chips, we work with Microsoft as well. Everybody's chips has got some of their own intellectual property in it, in top of ARM's intellectual property. And for that, we get a royalty and some licensing money. That's how we make money. Now, the other thing we had to do, Hermann had written all this stuff in BBC Basic. We had no literature for ARM. So the first thing we had to do was create books. This is the first book on the ARM RISC chip, a programmer's guide written by Alex van Sommeren and Carol Attack. Another one was the Advanced RISC Machines Architectural Reference Manual, written by Dave Jagger. Another one, this is where Steve Ferber comes in. This is about ARM system on chip architecture. So basically, and this is what I have to, of the 12 founding engineers at ARM that Hermann gave me, they were outstanding because in only 12 engineers, they could go from detailed chip design, the VLSI layout, but they also wrote the BBC operating system. And that's the other thing about this Raspberry Pi Acorn machine, is still running RISC-OS. So when we looked at this, we had one semiconductor partner, VLSI, one operating system, RISC-OS, and we're going to turn it into a global standard. So basically what I said is, we're going to partner in multiple directions. We'll have silicon partners who will make chips, and they'll sell those chips to the end customers. Typically, again, what we did, we got Sharp to sell Nintendo to Nintendo for the Nintendo Game Boy Advance. We got VLSI Technology to sell to Apple. We got Texas Instruments to sell to Nokia. So the whole idea of ARM is about partnership. And if we look at how that's worked, so this is the other good news. So when about the time that Acorn was the start of ARM, I think about 100,000 ARM chips were sold a year. By the time I retired in 2007, it was 10 billion. And last year, the ARM community, because it's all the semiconductor partners, shipped 25 billion chips in 1 year. So we have created the most popular microprocessor on the planet. The good news, of course, is every engineer at school now is being trained in ARM. So the good news for ARM is all of that momentum. And the other thing I would say to you is that it isn't just ARM engineers that have contributed to ARM. It's people in Microsoft, it's people in Apple, it's people in the tools partners, Caithness. So what you've got is you've created a community, and this is real the message for the world today. We get more progress through collaboration than we do with fighting each other. So I'll pause for there.
Absolutely right. And I think, in a way, the most remarkable thing that you did, Robin, is that at a time when you had 12 engineers, you had $1.5 million competing with hundreds of millions of the big companies. At that time, you decided that that we're going to be a worldwide standard. I find that absolutely remarkable that you did that. And you know, from the beginning, you thought that we had a chance of becoming a standard, and we have. Maybe I just tell the story of what happened to the 1.5 million. Because I became friendly with John Scully, who ran Apple for a while. You can look this up on the internet. I asked John how he felt about ARM and whether he thought that was a good investment that he made. And he said, yes. And actually, he said, if we had not been able to sell that $1.5 million investment in ARM for 800 million at the time, Apple would have gone bust.
Yep.
So actually, we are responsible for the survival of Apple, which now has become the most valuable company in the world. It is an absolute remarkable aspect that actually not many people know. But if you type in John Scully and ARM, you'll find that quote of him on the internet. So it's not me saying it, it's John Scully saying it.
So maybe there's one other thing I'd just like to add, by the way, which is, so when we started ARM, so Acorn had developed this RISC computer, and the idea of RISC is it goes faster than CIS, which is complex instruction set. And so Acorn had created the first consumer RISC, so RISC at a price. And it's a bit like Japanese car companies have small cars and Americans have big gas guzzlers. So that's where they put us. But then we said, well, and it was apparent to me that the ARM architecture had the best performance over cost and the best performance over price. And I came up with the term MIPS per dollar and MIPS per watt. And everybody said, what are you talking about? RISC computers will never be used in mobile phones. But the advantage is, because of my experience, I could see that trend was coming. And also, you all know this, for the individual chip companies, they're spending a fortune designing chips. And by the way, a new wafer fab for TSMC today costs you about $20 billion. So it's no good designing a chip that you can't sell. So the benefit to the semiconductor companies of using the ARM architecture is you buy into a standard, you don't have to worry about the engine, we don't get paid if it doesn't work, you get the standard software, you get the standard tools. So the reality is, in the same way that TSMC in supplying wafers to the industry does a more cost-effective thing, so ARM providing the intellectual property does the same. And the semiconductor industry has just become more complex, and that's how we managed to do what we managed to do. The other thing I would say is about the quality of the people. So again, in terms of the quality of the 12 founding engineers, we also had a concept of brutal honesty, which means if you're talking rubbish, I can tell you, even if you're the boss, right? So what we have to do is because that's with engineering. If we don't get everything 100% right in the engineering, it doesn't work. So we have to be brutally honest. So I've loved my journey with ARM. Hermann, maybe we should move on to what you and I have done together since we left ARM, and I left ARM, and you founded Amadeus, and talk a bit about that now.
Yes, well, it was wonderful that ARM actually created an entire ecosystem of companies. As Robin already pointed out, the success of ARM is a combination of an outstanding design, and it is a very unusual story that the risk architecture that Robin has just mentioned was actually invented by John Hennessy and Patterson at Stanford and Berkeley, respectively. But the first commercial implementation of the risk idea did not happen in the United States, where it was invented, but in Cambridge, UK, by ARM. So it's one of the few cases where the Americans invented it and we exploited it. It's normally the other way around. So because this ecosystem became very vibrant, I got lots and lots of companies that wanted me to help them grow. And I first did this as a business angel and then started Amadeus. And then we made lots of investments in companies, mainly in ICT, until, as Dame Shirley mentioned, we made that investment in Solexa, which now is responsible for 80% of the gene sequencing in the world. And I went back to study molecular biology at Cambridge for a couple of years, and now I do more life science investments, mainly also in the interface between life sciences and computing. And then we started investing. Robin joined me on the advisory board at Amadeus. We are looking at companies together. Sometimes we invest together. So it's been a wonderful ride, which basically came about because ARM's success is based on two very fundamental breakthroughs. The first one was the low power consumption, because CISC is much lower power than CISC, and that's why we became so successful in mobile phones. But that alone wouldn't have been enough. The second and arguably equally important contribution was Robin's contribution to make an IP licensing company out of ARM and not a chip company. And maybe you could tell us a little bit about how you made that, because there was no IP licensing company at the time. Robin basically invented that, and he made it the most successful licensing company in the world.
So it's just down to experience. So by the way, I should go back to the 70s. So I was with Motorola in the 70s, and Intel was founded in 1968. And I think, you could make silicon wafers with an investment in a factory for less than £1 million. And today the latest factory is 20 billion. So basically, unless you've got very deep pockets, you've got no chance. And I actually said when we founded ARM, semiconductors are like steel. The person with the lowest price will win the business. And it was that simple, particularly with Asian competitors and lower costs and so on. So that was that. But this is my other experience, that with the S2, because we've done this on-chip design, everybody wants to design on silicon. So this is the trend that I could see coming. And it's the idea is you don't design on a printed circuit board, you design on the actual chip. The chip is your circuit. And again, with a microprocessor, you need software, you need hardware, you need architecture. And what Acorn gave us, because of the experience of the team from operating systems to technology, it had got all the answers to those questions. There were a couple of key things we had to do, by the way, where we had to change things. So one of the problems we had So the problem with the RISC microprocessor that Acorn gave us had a lousy code density. That meant that the memory footprint was too big. And basically, Sharp were really interested with Nintendo in using it, but the code density was rubbish. Similarly, Nokia, and this is where this guy called Dave Jagger comes along, who's in. He's got a Maxwell Prize for this. He's a really outstanding guy, and there are a lot of very outstanding people. Dave Flynn is part of this as well. But he invented this thing called FUM, which fits on the end of the ARM, and it basically it's a 16-bit implementation of the ARM, which is a better code density. So FUM, that's what changed us from all the other. We got competitors like MIPS, Motorola, IBM, etc. The FUM invention was absolutely pivotal to allow this RISC architecture to fit in all consumer products. Another major breakthrough was a thing called strong ARM. So ARM, again, as a company, wasn't great at high performance design, but in teaming with digital, we got an amazing performing chip as well. So throughout ARM's history, partners contributed to the ARM success. And again, what we'd say to them is, you can work with us and get a better result. So that's the other truth is, I happen to be the CEO and I get some credit, but the reality is there are hundreds and thousands of engineers across the planet in competing companies that have contributed to the ARM success. So we can thank everybody, really. And that's what I mean about collaboration and partnership.
Robin, you must tell people a story about China, because that was another one of your great success stories. Because the Chinese at the time, of course, wanted to have a national effort to have a Chinese microprocessor. But so, here enters Robin.
Yeah, but it's not just me. This is actually a guy called Jun Tan, who is Chinese. So I don't take credit for this. Jun Tan invented this idea. So the basic problem we had is every Chinese PhD was doing an ARM clone to rip it off, paid by the Chinese government. And by the way, this is back in 2000. The world has changed a bit since then. And what Jun Tan realized, he was a guy, by the way, he was born in Shanghai. He did his PhD at Essex University, and when I met him, he was a researcher at Rutherford Appleton Laboratories, and I hired him to set up the Chinese operation. His brilliant idea was get all the Chinese professors to come and dine and eat with us over the weekend and teach them all about ARM and get them to write textbooks on ARM in Mandarin, and let's give them all a free academic license. So this is how you can turn your enemies into your friends. So, and by the way, in the ARM world last year, 20% of ARM's revenue comes from China. So everything in China is based on ARM, which is why it's rather unfortunate that we have a slightly messed up political world, because there are some challenges at the moment. And Hermann and I are lucky to have retired when we did. The world is a little more difficult at the moment.
So, Robin, you told us the story of how you managed to become the processor in 95% of the world's mobile phones. You then mentioned strong ARM, and the strong ARM, of course, has grown enormously now to be a contender in the opposite end of the microprocessor spectrum, which is the microprocessor in the data center. Sure. Now, I knew the Intel guys quite well, including Andy Grove, who wrote a book called Only the Paranoid Survive. Yeah. And Intel was paranoid about Motorola, about National Semiconductor, about AMD. They never were paranoid about ARM. They thought ARM was a joke. They said ARM was just this stinky little thing that you ignore.
Well, that's the good news.
And what is happening now, to actually all of our amazement, Robin, we must be honest, is that we are the biggest threat to the Intel architecture that the world has ever seen. The last bastion of Intel, because they tried to, and Robin, you might want to talk about the Intel Atom, which were trying to unseat us as from the microprocessor slot in the mobile phone, and then I talk a little bit more about the data center.
So here's the reality. This is the problem with success. So the leaner and meaner you are, the more hungry you are, the harder you work. This is why startups happen. the trouble with a successful company is they become complacent. The other thing that is the practical issue is it's quarterly earnings, it's pressure on quarterly earnings. So I'm not quite as, I have a slightly different perspective to Hermann. Basically, big companies eventually fail. And again, you can look at mobile phones. So Motorola was the first one, then it was Ericsson, then it was Nokia, then it was the BlackBerry. So the reality with business is you have to stay honest. You have to, this is the brutal honesty bit, and you have to keep shaking yourself up to do it. So the reality is we were going after a new space that the other people hadn't thought about. And this comes to the MIPS per watt and the MIPS per dollar. So if you're doing something that nobody else has thought about, they don't notice you. And this is why startups make it great. And this is why companies come and go. So the other thing we'd say about Intel, they have a lot, I have a lot of friends in Intel. And the problem I would say very simply is the bigger the company becomes, the harder it is to make it work. And that's just human nature. This is the Peter principle. People get promoted above their level of competence, which is perhaps a good reason why Hermann and I retired quite a while ago.
Yes. So what has happened now is that the strong arm that Robin mentioned earlier has matured into the ARM version 9, which is the first version of the ARM after, I think, 15 years of working on the, I don't know, when did we bring out the strong arm for the first time, Robin?
It would be about 1994 or 5. I've got a picture somewhere. But by the way,
so more like 20 years.
We have to thank digital for that. The other thing, again, is really interesting. It's all about people. The majority of the people in digital who worked on StrongArm now work at Apple. And that's what the whole of Apple's design team is populated by those engineers. So that's the other good news. Companies come and go and engineers move around a bit. But it's a bit like, I happen to be a Liverpool supporter and I'm very pleased we finished third. That was a big breakthrough for us. But basically, you're as good as the people in your team and you're as weak as the weakest link. And, again, it's a lesson to everybody. Don't become complacent and try not to get too arrogant.
So the thing that has happened with the latest version of the ARM is after 20 years of developing the strong arm philosophy to become a really, not just a world leader in MIPS per watt or MIPS per dollar, but also a world leader in the basic performance itself. And we are now actually outperforming Intel even in the data center.
Yeah.
But we have the same combination of these two amazing properties that have catapulted ARM into the standard design in mobile phones. And that is the number one problem, or one of the biggest problems, I should say, in data centers is now power consumption. So you build data centers somewhere in Iceland to make sure that you don't have such a big cooling problem, etc. So the fact that we have much better power consumption than Intel is now a major advantage in data centers. But the thing that is an absolute killer of Intel, and some people are actually predicting the demise of the 8086 architecture because of ARM, which was inconceivable when we started, because Intel was always the 400-pound gorilla. And there is one additional thing that is now working in ARM's favor. And that is Intel stumbled at 10 nanometers and then again at 7 nanometers for one very interesting and unexpected reason. It was not that they're not very clever chaps, which they clearly are, but one of the basic reasons for their success was to be the standard in the PC that was the highest volume chip in the world, and therefore they could outcompete the Sparks and all the other microprocessors that were in mini computers or mainframes, because they just had the volume. So their economies of scale were also better. So what happened to them with the rise of smartphones? The volume went from PCs to smartphones. So they now were simply not big enough to keep up with TSMC and Samsung, who were the main producers using the ARM license of microprocessor and smartphones. So one additional advantage of the ARM architecture, which really was very unexpected and is the greatest accolade that I could pay to Robin, which was his original idea of a standard. Because it is a standard now, just in terms of wafers, there are 10 times as many ARM wafers being produced in the world than Intel 8086 wafers. And that is now contributing to the demise of the 8086 architecture.
Okay, but I just want to say something else though. So Intel is a chip company, and Intel is an ARM licensee, and Intel is paying royalties to ARM. So again, Intel has the same opportunity as any other semiconductor company to work with ARM. And the challenge for Intel, of course, is they haven't kept up with their manufacturing roadmap as well as TMC. So actually, ARM hasn't competed with Intel. In reality, is Intel in manufacturing is behind the curve of TMC. And what's really frightening, by the way, is TSMC is so far ahead of everybody else that they are the dominant supplier of all the wafers on the planet. And so again, ARM's relationship with TSMC, and again, a lot of our startups' relationships with TSMC is very, very important. But again, one would hope, again, me personally, I would love Intel to get their manufacturing act together and catch up with TSMC. That would be good for the world.
I totally agree with you, Robin. But when I talk to my Silicon Valley friends, they are very pessimistic about that. TSMC, and to a lesser extent, Samsung, is you're absolutely right. 80% of the foundry business is TSMC.
Hermann, just to play the optimist back at you, remember the basket case that Apple was when Steve Jobs came in and turned it round, and remember that we were going to fail totally and we were mad. So never say never. So so for Intel, it's about management, people, focus, and all the rest of it. So, I wish well.
And I absolutely wish them well. And one of the most important decisions that they've recently taken, because they can't compete in volume with the 8086 architecture with the ARM, because the ARM volume is, if you just look at the numbers, Intel has become a niche player in our market. We are producing 20 times more microprocessors per year than Intel. So we've got, if you just looked at the numbers, the numbers of this.
So we don't make chips. We are not competing with Intel. ARM semiconductor partners are competing with. I'm just, again, one of the other things Hermann and I have been talking about is, depending where you sit, we have a different perspective. So Hermann is very proud, rightly, of the invention of the ARM architecture, but real life is a little more complicated. And by the way, it's become very complicated today. So the reality is that the whole of the semiconductor community competes with Intel, but ARM does not actually compete with Intel because it's an IP licensing model. So I'm just collecting the details.
I think that is absolutely the crux of the argument, Robin. And I want to add one more reason why ARM is being so successful in the data center now. And again, it is Robin's business model of licensing. Because the data centers, of course, are an incredibly concentrated market with Amazon, with AWS, and Microsoft with Azure, and Google, all completely dominating the data center. And what has happened is the following advantage of our licensing, that companies like Amazon have realized that, of course, they can produce their own processor for their own data center, as they've done with the Graviton 1 and Graviton 2. So if you look at the rollout of Amazon data centers now, more than 50% of the new data center microprocessors at Amazon are now ARM-based. I mean, it is a phenomenal turnaround from the 8086 architecture, which people thought was completely unassailable in a data center. Microsoft with Azure have also produced their own ARM-based microprocessor for their data center. They're the second largest data center company in the world. And now there is one very compelling economic reason for them to go to the data center, to produce their own ARM. Because if they buy the 8086 microprocessor from Intel, they pay $700, $1,000, depending on the quality of the chip. And of course, Intel needs to make a 50% margin. And now, and it's the most important chip, the most expensive chip they buy in the data center. And now that 50% margin is Amazon's or Microsoft, because once they've invested in their own chip, they just go and have it produced by TSMC. So it is that ingenious decision of Robin, at a time when he had absolutely no reason to believe that the ARM will become a standard, to go into the licensing business. And we've got to thank you, Robin, for making ARM the world standard, possibly now in the data center. I mean, it is not inconceivable that going forward, because ARM is making such fantastic inroads in the data center, that in the same way that the internet protocol finally decided on TCP/IP, and the networking community finally decided on internet as the standard for, on Ethernet and standard of everything, that the world will decide from now onwards, if you want a microprocessor, the only sensible architecture is ARM, because the ecosystem, the interface of the instruction set, the ecosystem sits on top of the instruction set, just makes it so much easier, and we can all work on the same standard. And the person who did it is Robin.
Well, it's not just me. Hermann gives me too much credit. So basically, the other thing, perhaps that's the other thing I should tell you, is when we started the company, of the 12 founding engineers, I got them to do this SWOT analysis, which they did. And basically, it says we had no marketing resource, no manufacturing technology, but we had so few strengths. There were very few things we could do, but what I want to say is this is very much a team effort, and everybody contributed to that. And fortunately, it's worked. The other thing I want to say is I retired in 2007, and when I retired, it was only 10 billion chips, and now it's 190 billion. So there's been an awful lot of progress by a lot of very talented people working together very well. And what's pleasing is the partnership business model. This is another idea. If you listen to the voice of the customer, so this is just, again, very simple. For disk drives, they need more real-time debug. So we put that into the architecture. For the mobile phones, they needed better code density. So basically, what I think has done very well is listen to the voice of the customer and adjust its roadmap to their needs, and fortunately, it's continued to do that. So, and again, the other thing, again, as a warning is, the minute you stop listening to the customer, it takes years to build a successful business. It doesn't take very long to kill it. I'm wondering, Hermann, I'm sure there's a lot of questions, and you and I can go on about lots of things. I think it might be good to just open it up to the audience, and we can kind of talk about anything, if that works for everybody else.
Happy with that.
That'd be good. We've got some questions in the chat. Hermann, you mentioned the importance of design tools in general. The open source operating system used on many, if not most mobile phones is Android, but the design tools for Android are owned and controlled by Google. Android has accordingly been described as the least open source project in the world. Do you agree or disagree?
I agree.
By the way, I think there's an aspect of design tools that Hermann hasn't touched on, and it's the silicon design tools. And this is where VLSI Technology, so VLSI Technology was the chip company that made the chips for Acorn, and they had actually the best system on chip design tools at the time for getting the chips right. So as you've got the software side and you've got the hardware side, and of course, the chip, so this is the other problem of something so complex. There are many types of design tools, and there are many, but it's worth saying that it was VLSI Technology that provided the chip design tools.
The next question,
Hermann's right, they invented the software.
The next question is, before SoftBank's recent retrenchment, ARM was building chips for the first time. What is your take on the more recent developments like this?
So to say that ARM is building chips, ARM has dabbled with chips, but I don't think ARM has never been a chip manufacturing company. So, I mean, by the way, I spoke to a guy called John Biggs the other day, and they actually have the first plastic ARM working. It's only running at 100 kilohertz. So as an R&D company, you have to try things, you have to do things. But Arm is not in the chip manufacturing business per se in a major way. Again, under SoftBank, it's dabbled in a lot of things. It's done a lot of acquisitions. And to be honest with you, I don't know all the stuff they've done. I'm not really competent to talk about that. I don't know if you know anything about that, Hermann.
I think it would be very dangerous to fiddle with your brilliant business model, Robin. ARM has become the world's most successful licensing business, valued at 40 billion at the moment, because it does not compete with its customers. And one of the great dangers in the takeover by NVIDIA is that a single licensee producing chips will compete with the other licensees of ARM, and we've got to stop that that takeover.
The next question is, do you have a view on the next substrate now that we have reached the atomic level of silicon with IBM's 2 nanometers chip?
Well, the first thing to say is that 2 nanometers is not 2 nanometers. This is a very confusing thing. The smallest dimensions of the 2 nanometer processor is actually 12 nanometers. And the reason why people call it 2 nanometers is because we've had a roadmap in the semiconductor industry, which was always characterized by the minimum dimension that you need for a transistor. And the 2 nanometers, but what has happened, the transistors were always on a plane. So they were always 2D. But what has happened in the industry, the transistors have become 3D. The gates have become vertical. So the gates sort of wrap around this ridge that is now a transistor. So it's become 3-dimensional. So the 2D, the 2 nanometers comes from the fact that if we had stuck with the 2-dimensional thing, we would be at 2 nanometers now if we hadn't gone to the 3rd dimension. It's a peculiarity of the naming of the industry. But to answer your question, the answer is quantum computing. So as you rightly say, when you get down to nanometers, atoms are an angstrom, which is 1/10 of a nanometer. So now some of the transistors are playing with just 30 electrons. And at 30 electrons, you get into the statistical aspect of thermodynamics, which is getting a bit dangerous, because if 20 of them decide to do something else, you've got an error in your transistor. Now, when we go to quantum computing, we are actually beginning to compute with, say, a single spin of the spin of a single electron. So that brings the dimension down to an angstrom, which is absolutely remarkable. And we've made a number of, I'm a physicist originally, and I'm just having a ball at the moment looking at all these quantum computing architecture. And to my amazement, I found one in Innsbruck, my hometown in Austria, that now has a very efficient quantum computing architecture. And one of my, hopes for the rest of my life is that we might be able to contribute to an efficient quantum computing architecture after we've done the world's most efficient processor for classical computing.
Next, was the acquisition of ARM by SoftBank a good thing, in quotation marks?
Don't think so, unfortunately.
It wasn't as bad as it could have been if it was Intel or another chip company, because at least they were neutral. At least they retained the business model of the licensing model. But this would not be the case if NVIDIA got hold of them.
How do you see that being resisted?
Well, we're making good progress. The British government with the CMA now has a serious investigation in this, and it would be, madness, in my opinion, for Britain to give up its own in this new world where technology sovereignty is so important, and America in particular uses it as a weapon. Trump weaponized technologies to coerce other nations to do his bidding. And if we give away our main bazooka in this area, which is ARM, the only globally relevant IT company that we have, Britain would lose one of its main assets. which I think would be terrible. So you asked about progress. So the progress is with the CMA, which is the British government. The American FTC has an investigation running now. And fortunately, of course, Amazon, Microsoft, Google, Tesla. Tesla is pretty, very few people know that the Tesla chip, and the Tesla is, of course, an ARM-based chip for their CNA, their neural network chip, has 12 ARMs in them. So they're all objecting to the NVIDIA takeover with the FTC, with the American organization. Europe, both Infineon, NXP, and ST are objecting through the European competition law. And of course, the Chinese are also against the deal. So my hope is that that deal, I now think there's a better than 50% chance that this deal will not go through.
This is a question to Robin Hermann. What are your latest investment darlings stroke bets?
Herman, I think you should tell them all about the wonderful GraphCore chip.
Yes, Robin and I have invested in a Bristol startup with people that we know very well. Simon Knowles, who together with Sophie Wilson. Sophie Wilson, I think, is the only person on the planet that can say that she has produced 2 chips. One, of course, is the ARM chip, but the other one is the Firepath that very few people know about. 2 chips that most people on Earth use every day. The ARM through the smartphone, but the Firepath, 80% of the ADSL lines of the fast internet access that everybody has at their home are based on the Firepath, the Broadcom chip, the Acorn chip that we sold to Broadcom. And the GraphCore chip is one that both Robin and I are supporting, this Bristol startup. And this chip is at the moment the largest chip in the world, with almost 60 billion transistors. And it's the fastest AI processor in the world. So with a bit of luck, Britain will also be a major player and competitor to NVIDIA in the AI processor market.
And what I should say, by the way, that chip is running in 7 nanometers. So this is TSMC's most advanced manufacturing process. And whereas traditionally they have built their first chips for some American company, the first chips they built in 7 nanometer were for GraphCore. So Hermann and I are both very excited about the opportunity. The challenge, by the way, it's a bit like ARM. You need software, you need models, you need all these things. So it's all great. It's great having some wonderful technology, but to fan this out, you need a lot of tools, you need a lot of stuff, and it takes time to create everything. So, but we're very excited about the opportunity, and this is undoubtedly the world's most advanced chip.
And again, we've got 2 outstanding people here with Nigel Toon as the CEO and Simon Knowles as an absolutely brilliant architect.
Question for you both, I think. What's your view of the current UK tech scene? Any UK young tech companies to look out for? So are you optimistic, I suppose, that would probably be a good
So being very blunt, I think the UK coming out of Europe is the most stupid thing it could have done. ARM would probably have gone bankrupt without our collaborative R&D program. So I am very worried. Business is about collaborating with the best people, and also you need a large enough community. And this isn't about what your nationality is, but when we started ARM, we had Plessey making chips in England. By the way, this is good news. It's another startup I'm involved in. Plessey is making gallium nitride light-emitting diodes from micro LEDs. Facebook are hopefully going to use these. So there's some good things going on. But here's the bad news. There's no real modern silicon manufacturing in the UK anymore. There's very little in Europe. There is some in Europe. So basically, for Europe and the UK to compete, we need to seriously collaborate, particularly when we look at the fight between China and America, which is a really, really scary place to be. So I think the good news is, if you're GraphCore, we can do the best designs in the UK, and we could get them made by Taiwan Semiconductor Manufacturing. But honestly and truthfully, again, I'm not a politician. There's a lot wrong with Europe. There's a lot wrong with the UK. But I think the problem we have in politics, it's like 200 or 300 years out of date. So I am the world is quite difficult today at the moment. I mean, by the way, great design can happen anywhere, but the other problem is money. You know, a wafer fab that costs you 20 billion. What's your take on this, Hermann?
Well, again, I need to completely agree with you on Brexit as well. As a great Anglophile, I've spent decades of my life, and arguably the best life in Britain. I love the UK, but at the same time, I'm a passionate European, and I'm not ashamed of that. So for me, Brexit was a bit like my parents' divorce. It was a terrible experience, and in my opinion, Brexit actually was the biggest loss of British sovereignty since 1066. And here is why. If you're serious about technology sovereignty, there are only 3 areas in the world that have a chance in hell of being technologically sovereign. And that's the US, China, and Europe. So despite Brexit, Britain will have to work together with Europe in the key technologies that need a big enough area like Europe to be successful. 5G is a good example. Now, fortunately, we've got Ericsson and Nokia as European companies that can be good competitors to Huawei and Qualcomm. And in the semiconductor industry, Europe has just decided to put $145 billion in getting back into the semiconductor game. Now, Britain just doesn't have the firepower, as Robin said. You know, these fabs cost 20 billion a shot. So, we've got to, despite Brexit, we've got to work as one and make sure that we get the technology sovereignty that we need, so that we are not dependent either on China or any new madmen in the White House.
You might say the same thing about aircraft manufacturing.
Everything. I mean, collaboration. Look at the success of ARM. It's come about through collaboration in spite of everything. And so the good news is, being slightly positive, we are still apparently in the collaborative R&D program. We're still paying a bit of money, but we're in a bit of a mess, and we need to wake up to reality on 3G, 5G, satellite communication, everything, and get real. The other joke is that, the satellite signals don't care whether it's England, Scotland, Ireland, or Wales, right? So we live in a world that's dramatically joined up, apart from politicians, unfortunately.
So it's a good segue to the next question. If China is cut out of global partnerships like the ARM community, has it the domestic skills and/or will to create an alternative community, beginning with the aspirations for AI chips?
So my personal belief is that it's the same way as Europe should not be disconnected from the UK. China shouldn't be disconnected from America and Europe either, because if you look if you look at the engineers in Huawei, they are fantastic engineers. They're at least as good as Apple. And the whole thing is total nonsense. The other good news is, in spite of politicians, people in companies are still working together. So my hope is that this is a political blip in the world, and we can wake up to reality. And again, same applies to bioscience and everything. The good news is the best people on the planet are talking to each other every day to do great stuff, right? And what I wish we could do is just bring our political leaders a little more into the real world. But again, just go back before we started on. When I was a kid, it was the brain drain, and everybody was leaving the UK to go to America for a job. The good news is we do have more good things happening in the UK than we did when I was a kid, including GraphCore. So we don't want to get too pessimistic. And again, my friend Azim Premji, who's the boss of Wipro, said to me, do you know why IT outsourcing is so great in India? The answer is it's because it's the one thing the government paid no attention to. So the good news is we don't have to worry about the politicians. We just have to get on with it and do it.
The next one is also, sorry, I was going to say,
I agree.
An interesting question. Do you think that TSMC's location in Taiwan will deter China from invading?
No, the other way around.
Exactly. Yeah,
I think what one of the big dangers is that Xi Jinping gets ahead of himself in trying to regain China's position in the world that they've had all through history, except for the last 200 years. The main goal of China is to get back to where they were for most of history. And part of that, in their opinion, is reuniting China and getting reuniting China, including Taiwan, which they clearly will. It's a question of when. The danger is that Xi Jinping wants to do it during his reign, and he might, because he feels so emboldened by the phenomenal success and rise of China, that he might do it sooner than is wise, and possibly by force once he gets stronger than the US in that area, which will not be too far away. Maybe I can just say one more thing, because some people in Britain are beginning to demonize China. Whether you like China or not, China is going to be the biggest economy in the world, probably now by 2028. We have to deal with China. We've got to engage, and we've got to work with them and the Americans in some way or another. To just believe that you can completely cut yourself off from China is just delusional.
Moving away from China, how would you advocate young people building a career in chip design? I think that's one for Robin.
Well, I think you could go and apply for some jobs at Graphcore. They've got some vacancies. That's a good start. I mean, seriously, the UK traditionally has been outstanding at design, whether it's hardware, software, invention, or whatever. And the good news is there are still people hiring. I think all of our startups, Hermann. So there are, and the other good news about joining a startup, you can make a big difference. So this guy, Dave Jagger, I should explain, he's a Kiwi. The reason why he for his master's degree at Canterbury University, he used the Acorn Archimedes computer. So because of the BBC microcomputer program, and because New Zealand was transmitting BBC programs, he got into the arm and we hired him as a young engineer, and he's had a fantastic career. So the good news is there are jobs anywhere. Dave got on a plane and came to Cambridge. And so what I'd say to any young engineer, what do you want to do? Where do you want to go? Obviously, with COVID, it's a bit more difficult to travel, but the reality is the world is your oyster. And again, I go to Bangalore quite a lot. Bangalore is an amazing place for new inventions. So the good news is across the planet, there's great stuff happening everywhere. And it's also probably worth mentioning that China has the world's most advanced computer built on multiple arms. So the reality is that there isn't a differentiation between the best in China, the best in America, the best in Innsbruck, or the best in Cambridge. They're all the best. And that's where the world is really actually at the same level. And to some extent, you can do something good anywhere, right? That's the reality. That's the good news.
Can you see quantum computing producing usable platforms and tools which will displace current tech? And if so, what timescale? That's probably for you, Hermann.
Yes. Sorry. The answer is no.
Yeah, I was going to say that. I was a bit surprised.
It will not replace it. You've got to think about it more like an accelerator for mainly optimization problems. So quantum computers, because most of them probably will need sort of sub 4 Kelvin environments to work well, will be in the data center. And they will be a bit like the graphics processors or now the AI processors. They will be processors, mainly sort of optimization processors that are particularly good at quantum simulation, for example, which is key for drug discovery, finding out how two molecules interact with each other, because they wobble all the time, and it's very difficult to solve the Schrödinger equation that tells you whether a ligand, whether a drug molecule, for example, can dock with a receptor or not. And quantum computers can that better than classical computers. Big logistics problems, big optimization problem in logistics, and also code cracking, of course, are things that quantum computers can do better than existing computers. However, there are large areas of computing that cannot be executed faster on quantum computers than classical computers. So classical computers will stay.
The next is a question about ESG, which I suppose is very relevant for Amadeus. Is ESG impacting the tech world in the same way as it's impacting other sectors? Do you see hot emergent areas in this interface of environment and technology? And I guess you basically touched on that with the power in data centers. But I'm sure
very much so, and people often forget that the most likely solution to the climate change are actually technical solutions. So we are funding lots of companies now in green tech, as it's called. One of the most exciting one is a Cambridge company called Exemplar that uses peas and soybeans to produce plastic bags. Now, these plastic bags are not just degradable, but they're actually food when they degrade for the environment. So it's the food that goes back to to feed the bacteria and the bugs that then can grow the peas and the soybeans again that we can make into plastic bags. So you then have a truly cyclical economy.
Many people know that I'm a glass collector, and at the weekend I was shown a substitute for polystyrene chips, which I hate, which is completely edible and also dissolvable. So the same sort of idea. Anyway, sorry, Robin, you were going to say.
I think we should touch on the climate and resource problem, by the way. So we talk about TSMC. The biggest problem for TSMC and their growth going forwards is actually water, right? And electricity and all these other things. So the other thing that will happen naturally, whatever the Chinese government choose to do, you'll have noticed that TSMC is investing in factories in America. So this is where I believe businesses can actually be ahead of the curve. So water sources, electricity sources, food sources. So the human problem of, we're gobbling up the Earth's resource. So the climate agenda and the resource agenda is a serious challenge. And I think, again, I'm more optimistic about businesses making the right decisions and so on. So I'm possibly less pessimistic. I'm not, who knows what happens with politics, but I do believe that you kind of form natural solutions. That's what kind of tends to happen. And again, I think the world goes through phases. We've just gone through the worst pandemic in our lifetime. We're still getting through it. I would hope that when we are through this as a world, there may be a resetting and a readjustment, and they're back to being more sensible, right? I mean, that happened. The National Health Service was created after World War II. So one hopes that there can be a refreshing and a new wave and a brighter future. That's what I hope for. But what I'm really saying is the resource of this planet, this is a serious problem, and climate change is a very serious problem.
Could Acorn have been saved, or was it doomed to the corporate cycle of growth and decline you mentioned earlier?
Well, it created ARM, by the way, and the shareholders did all right, so it wasn't so disastrous.
No, but of course it ceased as a computer company, and it could have morphed from a computer company to be a set-top box company, which we actually were quite successful in for a while. But at that time, we didn't have the right leadership to really translate that into a very successful company. It was a bit of a sad end to it, and the reason, of course, why Acorn was finally divided up into lots of different parts is that ARM was so spectacularly successful that it made more sense to give the Acorn, when we had a good shareholding in ARM, of course, to distribute all the ARM shares to the Acorn shareholders, and they did all very well out of that. And divide the company up into parts. One was E14, which did the fire parts chip with Sophie. So in that sense, it was another Acorn success that people actually don't talk about because it all gets completely dwarfed by ARM.
I want to put one question to you. Are you optimistic about our entrepreneurs in this country and their new ideas?
Yes.
And if so, why?
So am I. I see more high quality entrepreneurial-led startups right now than I've ever seen. It's a wonderful development, that I've witnessed over 30 odd years that I've been doing investments. That the quality of the people that are now willing to do that. So let me tell you about a key event that happened in Cambridge. And it's only happened about 5 years ago or so. The very best Cambridge graduates in science subjects made a beeline to the city because they were paid and still are paid silly money to become analysts for the big funds. 5 years ago, the first time, or join the big, KPMG or the big consultancy companies. For the last 5 years, for the first time, becoming an entrepreneur is amongst the peer group is equally valued to getting a top job in the city. So now the very best now are starting companies as well, and I'm just so pleased about that.
The other thing I would add to this is we've had a dramatic improvement in all of our universities, that business and management and marketing and all these things are taught to engineers. And again, when the Judge program started at Cambridge, you and I were both involved in that. So I think there's been a cultural change within the universities. I'm also involved in the Royal Academy of Engineering's Enterprise Hub program, and the quality of people and startups and ideas, honestly, has never been better. We just need to help these people, be successful globally, and that's the challenge. The nationalism globally is a challenge, I think, to everybody who lives on this planet at the moment. It doesn't matter where you live. We're just going through this difficult period, I feel.
Good. Well, listen.
Yes.
I'd like to sort of wind it up now, and just to thank you both for a wonderfully interesting evening that sort of spanned the last, I suppose, 30 years. And my maths are bad, maybe perhaps 40 years. It's been a wonderful, ranged over many, many subjects to sort of past, present, and future, and been tremendously interesting. So thank you very much indeed.